So first, let's prove that sigma an converge. So sigma an is this. This is an alternating series. We have minus 1 power n times 1 over n. 1 over n is positive for those values of n, 1 to infinity. It's also decreasing. The derivative of 1 over n is minus 1 over n squared. It's negative, so the sequence 1 over n is decreasing. And the limit of 1 over n is 0. We now need to show that Bn is either increasing or decreasing and is bounded. If we take the derivative of arctan of n, we get 1 over n squared plus 1. That's the derivative of arctan. And this is positive. So Bn is increasing. Is it bounded? The answer is yes, because if you take the limit as n goes to infinity of Bn, which is the limit as n goes to infinity of arctan of n, well, arctan of infinity is pi over 2. This is tan minus 1 of infinity. If you're not sure why, that's because tan of pi over 2 is infinity. So tan inverse of infinity is pi over 2. So if Bn tends to pi over 2 as n goes to infinity, that means Bn is less than pi over 2. The sequence Bn is bounded. Sigma an converge, Bn increases and is bounded, and therefore sigma a and Bn converge. This is our series, and let's call this part without the cosine an and cosine 1 over n squared Bn. We have n cubed times n factorial over 3n times n plus 2 factorial times cosine and this is an and this is Bn. I choose Bn as cosine of 1 over n squared because this is very easy to bound. Cosine is less than or equal to 1 regardless of the argument, and this is probably decreasing, so that's good. Let's show that sigma an converge. So we have 1 to infinity n cubed n factorial over 3n n plus 2 factorial. Does this converge? When I see factorial, I use the ratio test. So we do an plus 1 over an, n plus 1 cubed times n plus 1 factorial over 3n plus 1 times n plus 1 plus 2, that's n plus 3 factorial, over n cubed times n factorial over 3n times n plus 2 factorial. N plus 1 factorial cancel n factorial, and we have n plus 1 left. 3n cancel 3n plus 1. N plus 3 factorial cancel n plus 2 factorial. We have n plus 3 left. So this is n plus 1 cubed times n plus 1 over 3 times n cubed times n plus 3. This is n plus 1 power 4 over 3 n plus 3 n cubed. And then we take the limit as n goes to infinity of the absolute of an plus 1 over an. The highest power term in the expression n plus 1 to the power 4 is n power 4, and the highest power term in n plus 3 times n3 is n power 4 times 3 n power 4. And now you have n4 over 3n4, right? So you take the limit of n4 over 3n4, the n4 cancel, and so you get 1 over 3. And 1 over 3 is less than 1. So by the ratio test, the limit is 1 over 3 less than 1, so the series converge. We now need to prove that Bn is increasing or decreasing and is bounded. Bn is cosine 1 over n squared. The derivative of this function is, by the chain rule, 1 over n squared prime. The derivative of cosine is minus sine, so minus sine 1 over n squared. The derivative of 1 over n squared is minus 2n carry over n4 times minus sine 1 over n squared. Now minus and minus, it's plus, so you have 2. N over n4 is 1 over n3 sine 1 over n squared. This sequence is increasing. Is it bounded? Yes, because cosine is less than or equal to 1. The absolute value of cosine 1 over n squared is less than or equal to 1. Bn is bounded by Abel test. Sigma a and Bn also converge.